You ready?
Yes.
Do your hair? Okay. Welcome and welcome back. Hey, in today's video, we're gonna elaborate on a post that Roger put up involving a ruler, okay? This isn't gonna be math class, but it is gonna be smart, all right?
Maybe.
So, well, we'll perceive it to be smart and you can be the judge. Roger, without further ado, is 12 inches still 12 inches?
Okay. Let's skip that. Okay. Why don't you grab that ruler?
Oh, it is in fact 12 inches.
So he's going to be my lovely assistant for today. So what we're going to demonstrate here, we're going to demonstrate two basic rules, and you can use these rules with any kind of training, but specifically with kettlebell training. This is a kind of a difficult concept to get at first, but once you understand it, it's super simple and it's super useful. So we're going to demonstrate two things. One, we're gonna talk about center of mass, what it is, and how it moves, because it's not a static point. The second thing we're gonna talk about is moment arms and how they actually affect force. So first thing we wanna just illustrate this. So he has a 12-inch ruler. So go ahead and balance that on your finger. Okay, so you see it's balanced. By definition, balance is there's an equal force. There are equal forces on either side, or both forces are balancing, are canceling each other out. Now, if we were to slide this way, the force is going to come down that way, and this side is going to get pulled down by gravity, and the other side is not going to have an equal pull. Therefore, it's going to fall. Well, what does that mean? We'll get there. Now, so you see that balance is at 6 inches. So that's the middle. All mass, or all objects, have a center of mass. So this ruler is made up of individual particles, and all of these particles are being pulled down toward the earth by gravitational force, okay? That's just what gravity does. We're not gonna talk about gravity. We don't have time, nor do you.
It's heavy anyway.
Ooh, I see what you did. So you probably don't care anyway. So all of these individual particles are going to be concentrated in this one point, and that is the balance point. That's the center of mass. That's why it balances here. So this is an important point to understand when you exercise. And we'll probably do some more videos and elaborate. Maybe in a couple more, we'll show you how to actually use this stuff. So all of these individual particles are concentrated in this one spot, which is why it's not falling. So does this spot stay the same or does it change? Well, in fact, it changes. The center changes. If you have an equal amount of mass here and an equal amount of mass here, what happens when you add mass over here? It's no longer equal. So this point needs to shift, and we're going to see how that shifts. So go ahead and get one of those things. Get the small one first. So there's a little hole here. He's just going to clip it in. And what you're going to see now is there's mass. There's no longer, so this is the 6-inch mark that he's holding it on his finger, and you're going to see let it go. It's clearly going to fall. No one should be surprised if you are. Turn off this video.
Welcome to Earth.
You got other important pressing things. So what I found is it balanced right around the 3.5-inch mark. Is that what you're getting to? Okay.
Exactly.
So what you saw then is the center of mass of the object, the point of where it actually balanced, moved from 6 to 3.5. So if we look at this in simple terms, the center of mass moved toward the additional mass. Okay. Now go ahead and clip the big one onto the small one. So now what do you get? Right around 2?
Yep.
Okay, so you can see it's balanced. He's not holding it. It's not stuck to him or anything. It's actually, that's the point around which it balances. So now the center of mass has gone from 6 to 3.5 to 2. So not only does the center of mass of an object shift toward the added mass, but it shifts to the degree of the mass. So, or I probably say this better, the more mass, the farther the shift. Probably a simpler way to put it. So because this was a smaller amount of mass, it didn't shift as far, added more mass, now it shifted more. Now this whole thing is essentially balanced. These forces from a physics standpoint are balanced. So whatever is holding this in place is equal to whatever is holding this in place. Okay?
Fascinating.
Now, why is that important? So one, let's take away this rule. Rule number 1, the center of mass of an object is not a static thing. It shifts toward added mass. So when you pick up a kettlebell, so pick up something, so his center of mass is going to be roughly here, and go ahead and get that in the rack position. His center of mass has shifted from here up that way. and it's going to shift to the degree of the mass. So, or it's going to shift in accordance with this mass. So the more mass here, the farther this is going to shift. Now this is not a super heavy bell for him, so there's not going to be a crazy amount of shift, but there's going to be some shift. He's going to have to offset that shift with muscles, and we'll get into some other videos and we'll talk about that. But this is what we want to do. Now, we also, let's pick it up. Let's say you pick it up in a suitcase. Okay, so now rather than his anatomical center of mass being located here, rather than shifting up that way, it's now shifted down in that way. So he's going to feel muscles that have to offset this pull in that diagonal, or he's going to get pulled off balance. So that's why that's important. Mass, your center of mass shifts toward the added mass. Now, what this is also demonstrating is the importance of moment arms. So when you're looking at forces, so for an object to be balanced, the forces on one side need to be equal to the forces on the other side. So the forces here are equal to the forces here, or this thing would fall. Now look at the distance. Now the moment arm is the perpendicular distance between the axis of rotation, so his finger here, and the line of force. So the force, which is gravity, is coming down through here, and it's coming down through here. So gravity is interacting on these objects. That's the force involved. So what we're really looking at, just to make it a little simpler, is the moment arm is the distance between here and here on one side and here on the other side. You can see this has a much smaller moment arm than that. So this also gives us another glimpse into something that's important. The longer the moment arm, the less force you need to stay balanced, or the less mass rather. Okay. So if you're looking at torque, you need to look at mass. So let's say you're lifting a dumbbell or a kettlebell, that's your mass. It's not necessarily always going to be the same. So here's a small plate. This is 5 pounds of mass, or 2.3 kilograms of mass, to be more accurate. So if he holds that right here, so here's the force going to go through the center mass of this plate. It's going to go to his elbow in this case. That's going to be the axis of rotation. And you can see that the moment arm is not terribly long. He can make it shorter, pulling the elbow back. So now this is closer. Does that feel actually lighter?
Yeah, it's easier for sure.
So, and stick your arm straight out. Now this is the axis of rotation, and now the moment arm is going to go through here. Now it's not always, we're showing you moment arms at 90 degrees, and they don't always line up this way. So don't think that the moment arm is always the distance between here and your arm. It doesn't work that way, especially if you start to do stuff like this. Okay, it's not always that clear cut. So.
Yes. Did you order the souffle, sir?
I ordered it early. What we're really looking at then is the number on the side of something. So a kettlebell. So let's go back to our 28. So if Jeremiah does a press and he pushes it straight up, he still has to contend with that 28 kilogram mass, and there is going to be a moment arm between, let's say, his shoulder and his elbow at some point. He does have to contend with those moment arms. What happens if he pushes that bell way out here? You can see that, let's say this is his axis of rotation, and the gravity is going to come straight down through the center mass. Now suddenly there's a bigger moment arm. Okay, so it's harder that way. Okay, so go ahead and put that down. So two things again. When you have almost.
Almost. It's gonna be cool as hell.
So when you have mass added to mass, you have a shift toward the additional mass. That's rule one. Rule two is that when the moment arm gets longer, it's actually able to balance these forces. Because when you're really looking at torque, which is the effectiveness of a turning force, or a force is all linear. So let's not get all wrapped up in that. But we have an axis of rotation here. So what we're really looking at torque is, because this moment arm is so long, even though there's less mass, it is still able to balance the other side, even though there's more mass. And I know this stuff might seem unimportant. It might not seem like that big of a deal, but when you understand these basic rules, you can really make a lot of training decisions. A lot of people like to talk about form. Form usually for people comes down to how they've been taught. I don't care how you've been taught. justify your opinion. This is the stuff that you need to justify your opinion. You need to demonstrate why something is in a particular position. Do you want something to be harder or easier? More efficient, less efficient? Are you looking for power? The rules by which objects move will always give you a glimpse into what your appropriate form should be. So if you find yourself in a place where you're just kind of dictating, this is the sort of thing that I do, that's fine if that's where you are. But if you're going to argue about form, you need to understand some of the rules, and these are two really important rules to understand.
Cool. I like it. Anything else?
No, I think that's it. We'll do some more videos to show you a little bit more about this stuff. Perfect. Make it a little more practical.
Yeah, I like it. Hey, rewind, watch this again, and make sure you leave any comments or questions you have for this, even if it's like, wow, that was really confusing, or wow, that was really simple. Thanks for breaking it down. We want to hear from you. And remember, kettlebell smarter, get stronger, stay strong, live long.
Okay, we got to go.
All right.